Welcome back, everybody. And I found something. I found oxyacids in section 1.3a. I don't believe we talked about those. A little 141 review here. Or maybe this is 142. H3PO4 is phosphoric acid. And ic acids come from 8 ions. That's phosphate. If you don't know already, acids in this course have hydrogen ion listed first, and in most courses as well. And hydrogen, to be an ion, needs to be bonded to the most electronegative atom possible in the structure. So if it's bonded to phosphorus, it's not a hydrogen ion. They have the same electronegativity. So this would not be the oxyacid. That's the number one important thing to remember. An oxyacid has the proton, which is the hydrogen ion, H+, attached to the oxygen anion, O-. And when you have one less oxygen in the oxyacid, ic acids become OUS acids. And OUS acids come from ions that end with ITE. In this case, phosphite. And how do you memorize the eights versus the ites? You can't use the charge because they have the same charge. It's a relative thing. The 8 always has one more O than the ite, but you can't say 8 always has 4 O's because there's an NO3 minus here that has only 3 O's. And that's a very popular ion that you all should know called nitrite nitrate. And this makes this nitric acid. We haven't done Lewis structures at all here, just a little review. Nitrite ion, when you put a proton on it is nitrous acid. And sulfate ion and sulfite ion have the same charge, but the one with one more O is the 8. Gotta watch the Canadians, they'll throw a PH in there instead of an F on you. I'm tempted all the time. Sulfite. So the acids are called sulfuric acid and sulfurous. And down here we got 4 ions, so we need more words. The parents are here, chlorate and chlorite. Meaning this was chloric acid. This was chloros. We need a prefix that says one more oxygen than 8. We don't have that yet. And that's per. I think you were responsible for all these ions in 141. Perchlorate means this is perchloric acid. Very dangerous acid, by the way. Not only is it a strong acid, as in it is a strong proton donor, it also is a chemical that's highly oxidized, so it wants to undergo redox reactions as well. Perchlorates are usually explosive. And how do you say one less than? Per is derived from the word hyper. And you know, hyper means extra energy. I got accused in lab yesterday of having extra energy. And one less oxygen than an ite ion is a hypo. Hypo meaning below. Prefix like hypodermic means below the skin. And hypochlorite is this one here. And we're going to draw some Lewis structures very soon. I'm just going to pick one of these. Let's do the Lewis structure for sulfurous acid. We don't have to do all of them. You'll get the idea after just one. You got to count your valence electrons the normal way. You have 2 hydrogens, each with 1. You have a sulfur with 6. You have oxygens with 6, and there's 3 of them. That should be 26 valence electrons. Make sure. 3 times 6, 18. 6 more. Is that right? Yeah, 6 more is 24. 4 times 6 is 24, and 2 more is 26. Oxygens, you don't bond oxygens to oxygens ever if you can avoid them, and definitely we can. And do not attach the hydrogen to sulfur. That would not be an acid at all. You must attach the hydrogen to oxygen. The giveaway is the way the formula is written out. You have H and some atom in the middle, and then oxygens at the end. These are oxyacids. So you put the sulfur in the middle, surrounded by no less than 3 oxygens. And you pick 2 of the oxygens to have the hydrogens. Remember, we like shooting for symmetry. It helps us out with Lewis structures. All right. You have drawn no less than 1, 2, 3, 4, 5 bonds. You've used up 10 electrons for 5 bonds. You've got to come up with 16 more. We'll put them in black. Filling octets, there's 4. There's 8. Let's see. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12, 14. And you have no choice. You need 2 more. You can't put them on the oxygens. You got to put them on the sulfur. And if you finish with this, you're going to get partial credit. I'll tell you your score. 2-point question, you just got 1 out of 2. Because I always ask this question. Draw the most stable Lewis structure. And you forgot that sulfur is not limited to the octet rule because it has d orbitals available for bonding if it needs them. I got some extra stuff, but I'll live with that. So you're not finished until we're finished. So you say, okay, this oxygen would be a -1 formal charge. We don't like that if we can avoid it. -1, and sulfur would be +1. So you're going to take a lone pair off the minus, because if you share it instead of owning both, that'll bring the charge down. And sulfur will gain an electron and go up. Sorry, it'll become less positive. And I took the pair of electrons off, and now I'm putting it back on. You ready? And that right there is my final answer. The important thing is oxyacids have H attached to O. And that brings to a conclusion the loose ends for test 1. You'll see on practice exams in part 2, it's very common for me to make you draw an oxyacid. I think it happens about half the time. So I don't know if you're going to be doing it next Wednesday, but there's a good chance. And please email me with questions about things you want in review day. Review day is only as good as you make it. And I look forward to seeing you, and take care. We're finished.